just got in this morning.
You flew in?
Yeah.
Okay.
From Sacramento.
Okay. Okay. All right. Good.
And where are you located again? Are you
I live out in Pasadena.
Oh, Pasadena. Okay.
Are you familiar with LA?
Yeah.
Okay.
Nice,
So,
nice.
but our project, yeah. So it wasn't too far of a drive. But you guys just observing or?
Melissa's actually on this.
Okay. Okay. Okay.
But yeah.
Oh, you're going down there? Oh, you're gonna be here?
Yeah.
Okay.
Yeah,
Okay. All right. Which facility?
The one on Vermont. Like Carson, Long Beach.
Is it right up on the 110?
Yeah.
The allergy clinic we're engaged with.
It's called the South Bay.
Okay, there's South Bay, and then there's like another one. I think we're up there.
There's a huge one.
Yeah, with their allergy clinic.
Yeah, I never seen
Okay.
that on the map before, so I think it probably is.
Okay.
But it's probably right.
Okay. All right.
Swap a few.
Okay. Where are you staying?
I'm actually staying kind of near downtown LA because I've got a couple of events.
Okay. It's just you guys are. It's good that you guys are living in.
How's everything with you?
Yeah.
What do you expect?
From them. No, they're really engaged. So, when was it last time we talked? So they're in the process of, I don't know, you guys heard from them? Okay. They said they could definitely analytics. So yeah, so they're looking probably at September. They'll have some preliminary data. I don't know.
That's a good question. Actually, I'm not sure.
Okay.
It might be.
Okay. 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 Yeah, well, thanks again for that letter. There's a couple proposals coming out. March is, I don't know if you've done nonprofit grant writing. Yeah, it's a thing. It's always all but no, you guys do.
Just
Okay. Yeah, you guys are part of that. That was funded by UPS. Okay.
But yesterday was like a day ago.
Okay. Yeah, that's the Bay Area. Bay Area.
Their main headquarters.
I've had a lot of conversations with they're a big company. But right now. And there's like and then there's like some of the people are retiring after reorganization. But I think at one point, yeah, it's always fun. But at some point, because we have the champion. We're actually co-chair of the housing. So, so there's these processes. Yeah. A lot of times, She's coming
Yeah,
too? Okay, I
I
saw
just
her
I
name.
had some other work I had to do down here, so I
Oh,
decided
really?
to come
Cool. Great
early
to
this
see you.
morning.
Yeah, it's getting difficult with LAUSC. You don't hear anything like when they're busy. It's so my suggestion is just to go ahead, do the deployment.
Okay.
Talk to Nick. He said like even if they change the outlet, they just unplug it and plug it back, and it goes running. So hopefully all the rainstorms have passed. We're gonna get a little bit more this week.
Yeah, I know. I saw that. I'll be here all week too, doing some stuff down at the Kaiser facility.
Oh, really?
But yeah, it's too bad that they've been slow because it'd be perfect place to put
Well,
stationary
the good
sensors
thing
is
is
schools.
once we get the go, it's like 10 of them,
Yeah.
12 of them. So like suddenly like the actual network up and coming.
And is the problem that they're just different facilities people at each school? Is that what's making so? Or
I think it was first the strikes, and then they were insisting that they want to do their own contractor to change the outlet. So like just do it, and they refused that option. They're like, oh, we have to go through the process. I guess like several levels of approval at SCAQMD. But I mean, I'm hoping that the rainstorms have passed, so like I think it should be fine if we go just deploy. I mean, if one of them is more exposed, we can just I don't know make something, come up
yeah,
with something to
yeah. I mean,
temporarily.
it's pretty easy to put those little covers over and after.
Exactly. Yeah, yeah. We do it all the time actually, like because not all of our deployments are like for launches, right? So like you do that all the time. Like even at the beginning, I was telling Sumner like, is that necessary? Like, do we have to do that? All those outlets are up there. They're all running. Rains all the time. So like, uh,
Yeah. All right. Well, hopefully
yeah,
they're ready to go. So.
yeah, yeah.
Yeah.
And part of it is like I don't want to be annoying and call like several times a week as well. So like I call, I give them another follow up. I want to do another week, but you never hear back. So like,
Yeah, it's too bad they don't have somebody that cares about the cause a little bit more.
right, right.
Maybe if we explain to them how important this could be in the long run, then they would be a little bit more motivated.
Yeah, I've been swamped with so many other things related to 617. I'm gonna
Yeah, because you're
get,
hiring people, right?
yeah, like we're in that process right now to figuring out like the monitors, the personnel, and all of that. So like, I haven't been spending too much time actually on this, so like I'll get a little bit more proactive on
Well, but like
getting
you said,
something.
like somewhat overburden them too.
But one benefit right now is like we may be able to deploy both the G-Box and SPOT at the same time in one go, so that at least there's something positive parts of the story because of the delay.
Yeah, that's true. Yep. Yep.
Cool.
All right. Well,
Well,
good
great
luck
to
with
see
this.
you.
Yeah, you as
I'll
well.
catch up with you later.
Yeah. Are you doing that AQ Spec tour afterwards? Who's leading that?
Um, he,
Or would it be
Andrea, and
Andrea?
Aaron would be leading that, but I probably have to double check with you. We might have the mobile, our mobile platform also in the
Oh,
parking lot.
yeah.
So if we do have it, I'm probably gonna stay at that mobile platform.
Great.
But
All
I'll
right.
see.
Well, look forward to seeing that.
Okay.
That is, there are a number of stationary sensors that go to that.
Okay.
But we're trying to But it'd be, these things go. Pretty much. So I won't like. Our focus would be it's gonna be focused on. We had a roll call. Our original SWAT together. So we have to get another. So we have another one. Is that not proposed? Proposed river. Okay. So hopefully.
We're going to go ahead and get started, so if folks could take a seat, feel free to grab some of the refreshments and bring them over. Okay, that sounds good. All right, we're going to go ahead and get started. I just want to remind everyone that this meeting is being webcast, so should you want to review all the highlights or the lowlights of this meeting, you can certainly go back and find that on our webpage. We also have the capacity for folks who weren't able to attend in person but would like to ask a question, that they can send an email to, that's ab617_tag, TAG, at aqmd.gov, and we can receive those questions by email and try to get those answered through here. So good morning. My name is Jo K. Gosh. I think several of you guys have already seen me around many AB 617 meetings. So welcome to our very first technical advisory group meeting. I'm very excited for you folks to be here. Just as a quick reminder, remember that we have representatives from each of our 3 year 1 communities here. There are three members from each of those community steering committee groups, and in addition, we have additional technical experts, for example, from other agencies, academia, and other institutions who have specific technical expertise in air pollution modeling, air pollution emissions inventories, and monitoring. So with that, I'm going to go ahead and introduce the 2 folks to my left here. There's Dr. Jason Lowe, who's in charge of our Monitoring and Analysis Division, and Dr. Sang-Mi Lee, who will be running this meeting today. So, go ahead.
Thanks for the introduction, Jo K, and thanks for everybody to attending this meeting. So this part kind of still we are ongoing for the first item, welcome and introduction. So I think we should introduce ourselves starting from the technical advisory group members sitting on the table, and then we extend it to the general public in the back. So we'll start from myself, Sang-Mi Lee. I am a program supervisor in air quality modeling and emissions inventory at South Coast AQMD. And then to my right.
Good morning, my name is Good morning, my name is Khadija Abdullah, and I am an air quality specialist here at the AQMD.
I'm Mark Carrera Sospedra. I'm an air quality specialist at AQMD doing emissions modeling.
Payam Parkbin, Program Supervisor, Special Monitoring, AQMD.
Hi, my name is Melissa London. I'm the Chief Scientist at ACLIMA, a technology company.
Just one touch. It's just one. Yeah, gentle touch. Yes, now it's good. Yeah, the green light.
Tammy Yamasaki, San Bernardino Steering Committee alternate. Thank you.
Marissa Blackshire, and I lead BNSF Railways Air Programs.
Good morning. I'm Sunny Ivy. I'm an assistant professor at UC Riverside.
Andreas Beiersdorf, Cal State San Bernardino, and I'm on the San Bernardino committee.
Good morning. I'm Janet Wittick, Director of Policy at the California Council for Environmental and Economic Balance. I'm also on ARB's AB 617 consultation group.
Good morning. Uduak Jointuk, Patrol Administrator of the City of Los Angeles, member of the Wilmington, West Long Beach, and Carson group, and a resident of Long Beach.
Good morning. Rafael Yanez with the, representing the East LA Boyle Heights communities.
Good morning, Andrea Polidori. I am the Advanced Monitoring Technologies Manager at the South Coast AQMD.
Good morning, Aaron Katzenstein, Laboratory Manager, South Coast AQMD.
Good morning, I'm Luis Portillo. I'm Director of Public Policy for the Inland Empire Economic Partnership.
I'm Trey. I'm from AQMD and I work for the modeling group. Thank you.
We're good. So before we start, oh, sorry.
There you go. Even better. Hector Garcia. Wow, yeah. Hector Garcia, Our Lady of Victory.
Great, thank you very much. So before we begin, there's a few housekeeping measures that we'd like to just go over and remind everybody. So first is that most importantly, there are public restrooms towards the back. You exit through 2 sets of doors and over to the left. And then speaking of exits, if there was an incident such as an earthquake, be sure to shelter in place. And when it's safe, there are 2 exits, one in the back and there's one in the front. And then lastly, this is a public meeting with some presentations, so if you could please check your cell phone, make sure that's in silent or vibrate mode. Thank you very much. And with that, I'll pass it over to Dr. Sang-Mi Lee.
Okay, came to me again. So now second part of introduction. So people in the back, could you please introduce yourself? Can we just?
Tim DeMoss with the Port of Los Angeles.
Okay, thank you everybody for introducing yourselves. So we'll start the presentation. So first one is the emissions inventory and chemical transport modeling, and I will be presenting this item. So here, my presentation is going to mostly discuss what types of emission inventories we are developing here, and then how those inventories will be used, and then how this, when inventory is going in, emissions going into this, our technical analysis system, in other words, numerical modeling, what kind of modeling we are using, and then how those perform, and then how we are going to improve to reduce uncertainties, etc. So then, first of all, why we are doing this? Most of AB 617 community steering meetings so far has been identifying the concerns that residents have, and then available data we have, and then the plans to monitor and then to improve air quality so far. But then given that this is very technical discussions on the modeling, air quality modeling and inventory and monitoring, why we are delving into this kind of technical discussions. The reason are twofold. The first one is as is defined in ARB's Blue Book. So first reason is we needed to identify what is causing the air quality concerns in this individual community. And then second part is if you know, let's say you know the sources of the air quality problems in a community, how we are going to quantify our progress that we are the progress to be made through our promises during this process. So first one, again, it's identifying the problems, and second, more or less quantifying the progress we are going to have. Then with this two in mind, I'm delving into real technical discussions. So how do we develop emissions inventory? Since emissions inventory is pretty much the backbone of all these discussions, we needed to know, we needed to aware of these details of emissions a little bit. And then when we start talking about emissions inventory, the first question is, what are the source categories? So there are 4 major categories that we discussed in the previous CSC meetings briefly as well, but very, very briefly, the sources are point sources, area sources, on-road mobile sources, and off-road mobile sources. Then each of these sources, depending on the source types, the approach to develop emissions inventories differ. So first of all, point source, in a way, it might be the most defined source category among all of them. So point source, in a way, you can always see, as shown in this picture here, that is the factory, that is the stack you can see from anywhere. And then larger facilities that existed within our air basin are required to report their emissions to AQMD by through our annual emissions reporting system. So this is annual reporting of criteria pollutants and also toxic air contaminants. And then what is the threshold of the responsibility, that the threshold of the facility that has to take this responsibility? There is a threshold that facilities emitting larger than 4 tons of VOC, NOx, or SOx, and PM are required to report to us. But then CO threshold is a little bit bigger because the CO, it is much larger amount than other pollutants. But then anyway, through this annual emission reporting system, we have quite good understanding of the natures and locations and emission amount from these facilities. And then these emissions later on, we also speciate into more detailed toxic air contaminants that was used in the cancer risk exposure estimation. Second category is area source. This is kind of, intuitively we know, but it's a bit challenging to quantify this source in emissions inventory due to the nature of it. So area sources, in a sense, let me say in this way. So you, let's say any resident or any of us are painting your house, then that paint emits a volatile organic compound. But then you cannot model or record every single person who is using such product products. That's why we have to kind of track in a larger scale, such as the statewide consumption data, and then convert that into emissions data, and then locate it in a specific a place where the human might be more likely to use such products. So those are generally area source categories. Again, it's through this more larger scale statewide or countywide consumption data or sales data, etc., depending on the specific sources. And then these sources, again, the challenge is how to locate. Let's say, again, this the consumer products that you're using to clean your toilets and bathrooms, or hairspray or paints, where to place them in the modeling system. So the real world system, it's very irregular, like it could be polygon shape, line shape, or points to point, just a point that has to be located in this grid shape. That's how this numerical modeling or this exposure analysis ultimately we conduct. So based on where the population lives, where the household lives, where the multi-story house or single-story house exists, so we collect all those data, or more accurately, we utilize such data that through the data depositories such as S3's ArcGIS or ArcGIS, we allocate those accordingly. Third category, on-road, it's easier to visualize. So those are all the mobile sources that runs on the road. And then these categories, the next slide would be a little bit easier just to conceptualize. So this category requires multiple components. One, we need to know how many vehicles are out on the road. And two, we needed to know how many miles individual vehicles drive. Such information coming from SCAQ, Southern California Association of Government. It is their responsibility to estimate and then predict future the vehicle activities. And the second portion, that is the very right in the called travel demand model. And then second component is MFAC. That's ARB, Air Resources Board, is primarily responsible to maintain it. But that what MFAC does is, depending on the age of a vehicle, or types of a vehicle, or the usage of vehicle, how much pollutants coming out from individual vehicles. So emission rates are estimated through this MFAC component. Third one, the meteorological factors such as temperature or relative humidity affect the emissions from a vehicle. Let's say if it's hot days, there will be more volatile organic compounds evaporate from your vehicles, for example, gas tank. So this meteorological factor has to be considered. So you put all these different components together and then space them accordingly. We call the gridding. Then you come up with the total organic compound and PM, the emission factors from on-road sources. The last category is off-road category. Off-road is like, for example, forklifters in the warehouse. So you can move it in principle, but then they are not necessarily on the road. So it is moving, but not on the road. So those types are called off-road sources. Some of the categories is kind of well tracked through ARB's reporting system. It's called doors. And then some of the categories based on the survey data. So we get the most best available activity and the population meaning the number of equipments existing in the basin or in the county, and then apply the emission factors and get the emission data for this category. So so I'm talking about all different types of emissions inventory and emissions category, but then let me have your attention to what data we are using it, what platform we are developing this type of data. So the most recent kind of integrated developmental effort was like 3 years ago through 2016 Air Quality Management Plan, AQMP. And then prior to that was MATES-4, that's multiple air toxics exposure study conducted in 2012 and 2013 timeframe. And these two were example of two complete studies that has extensive amount of effort went into come up with a complete holistic kind of compiled emissions inventory. And then currently what is ongoing is MATES 5. That is, again, multiple air toxics exposure study series, but it's the fifth of the series. Its measurement monitoring is ongoing, and then also emissions inventory development, refinement, and then toxic exposure estimations are ongoing. And then of which result we hope to be able to be available maybe in next year or so. But then when we talk about the exposure estimate or the health effect, criteria pollutants important, but at the same time, toxic air contaminants, which are the amount-wise much lower than criteria pollutants, however, may have a higher implication on health effect, are needed to be considered. So these are list of air toxics that were included in MATES 4 analysis. But then now I'm delving into kind of a spatial, more graphical, the result of the analysis. So through the MATES 4 analysis, the diesel particulate PM was identified as a main cause of the cancer risk in the basin, which holds true for all the three communities selected for year one. So these are kind of to have idea how this diesel PM is distributed, how much are coming out, and then where are the hotspots of such emissions existed within the basin. This is maybe a bit challenging to identify. Can I have the mouse? It's actually, yes. So let me try, I can see, yes, I can see the mouse. So these are the coastal lines through the San Diego all the way to Santa Barbara. And then very busy, the lines here are associated with the ships, ocean-going vessels. And then this thin black lines are county lines. So generally these are port area. Here is central Los Angeles. And then this is Riverside County. Here is San Bernardino County. You kind of have the lines popping up. Some of them might be associated with the on-road sources. Some of them might be activities in ports or rail yard. We will see in the subsequent slide. So first, we split out the on-road portion of diesel PM, and this is supposed to follow the freeway locations closely, and which holds true. So this is Interstate 10, and this going here would be, I presume it's Interstate 5, and then some of them, this even 710 is identified here, and then other freeways, you can see it here. So what we can see here is this diesel emission from on-road source categories, as intuitively we would expect, follows the mobile source, the vehicle travel tracks closely. And secondly, this is off-road, off-road mobile source category. Again, there is no freeway marking here, but what you can see is this is probably cargo handling or port activities associated with these two ports. And then another hotspot you can see here could be associated with rail yards that going this north-south direction. And then some of the activities could be some construction or other off-road activities identified in Riverside County area. Next one is ships, ocean-going vessels. And then these are so-called shipping channels, so a kind of loosely defined the path that the ships traveled within our basin. So the port has a highest emission, but then from there going away, you can see there's less amount, but it follows shipping channel location closely. And then also this could be Camp Pendleton area or Oceanside. And then next category is a train category. This one, the train goes on the train path, rail path. So these are the location of rail yards in our modeling analysis area. And that's it's kind of well distributed, but then you can notice these hotspots in the Los Angeles County area. Stationary sources, this is primarily point source. This is combined point and then area sources. These sources, as you can see from the name, does not move, and then locations are fairly well identified, and then lots of the business locations or facilities identified under this category. And up to here, what I presented was the result that was developed under MATES 4, which was the result was the final report came out like about 4 years ago-ish. But then we currently trying to improve all this analysis by incorporating more state-of-the-art data and measurement data. So for example, the on-road data I presented in a couple of slides ago were based on the SCAQs, the vehicle activity data. Those activity data is actually more or less present average days of a year, average day of a year. So it does not necessarily reflect, let's say, Sunday during summer month, people would go to beach a lot more. And then another day in the winter, it's rainy day, then people might not drive as much. So that kind of day-to-day activity and location-to-location activity is in a way well recorded through traffic sensor data. This sensor data is when you open your, for example, Google Map and then see where how traffic is. Those are based on sensors that located along the freeways and roads. And then we collect all those data and then reallocate the mobile source emissions to reflect this real world human activity and then climatological, not climate, weather conditions. And then second one is in the earlier, this emissions from ocean-going vessels, you saw well distinctively defined the shipping channel. But then another source of data that enables us to take a second look of such activity is this automated information system. So every ship that travels all over the world has this ship tracker through the GPS system. And then we utilize this real-time data to reanalyze the location of ships and then identify the types of ships and then try to use this data to refine emissions from ocean-going vessels. And then this is one example of how this the updated information looks compared to the traditional method. So this left side is NOx emission. That's all the emissions are located along this kind of designated or predefined shipping channels. Versus this right-hand side is tracking all the ships through this AIS. And then as you can see, shipping channels are still valid. But then you can imagine out in the ocean, there is no lanes. So ships can deviate from 1 mile in either direction depending on accuracy and then operations. And then that is well represented in this real sensor-based data. Third one is aircraft. So again, when you do this analysis, what matters is what height the emissions are released into atmosphere. If it is right at the human breathing level, of course that has the highest impact. But if it's released, let's say far in the sky, we call it mixing layer. If it's above the mixed layer, the implication to the surface concentration would be much less than human exposure or human breathing height. So this information, we are using FAA's aircraft information, their locations and height, and then based on those, the sensor or location information, we are reallocating aircraft emissions accordingly. So not all the emissions are allocated at the ground level, but as you can see, it's allocated at different height based on the reported aircraft emission activities. Another category is recreational boats. This seems to be, perception-wise, this seems to be a very small category. However, amazingly, especially weekends, the activities and then emissions from this category can be very significant to promote chemical reactions. Then during weekends, for example, heavy truck activity is relatively small, so it is highly likely the chemical regime to promote this toxic formation or ozone formation shift to a different regime. So VOC emissions from this category does matter, and then the step went into the Google-based aerial photograph and satellite images to identify the activities and locations of this category and allocate them accordingly. And the next category is biogenic emissions. Biogenic emission is basically emissions from trees and vegetations and grass, etc. These we do not have direct control over. There is somewhere a way of doing it through some planning activities. However, given that we do not control these sources, but this has also implication to kind of shifting or determining the photochemistry, the formation regime. So STEP utilizing the satellite data, it is European satellite called the Sentinel-2 that provides imagery, what you can see in the right, in 10-meter resolution. With this satellite data, we are trying to carve out the vegetation information in urbanized area, and then estimate the emissions from those vegetations properly or correctly. These are, and then another improvement based on these discussions or questions raised through CSC, and then the areas identified by STEP and other steps from other agency is one, how to improve. Still, even our capability to estimate road mobile emissions already improved due to the real-time sensor data, but we further try to improve with such information, and then this time try to allocate emissions to every road that exists within a community. So there could be several steps of doing this. One, so far in traditional analysis, we were looking at so-called computational grid. This computational grid is like 2 kilometer by 2 kilometer, approximately mile and a half by mile and a half size rectangle box. So we necessarily do not look at details within the box, but then this newer approach, and then due to the necessity to identify more the sources more accurately to assist this community plan. So we are looking at individual levels, individual road. We will start with major arteries, but individual road and then ramps and then bluebirds, etc., that located within the community to come up with a better understanding or better estimation of on-road sources. And another thing also, some sources or some categories that was discussed during CSC meeting, for example, auto body shops. Let's say there is a small mom and pop, the gas stations around the corner of the street. That location is not necessarily well reserved in the traditional approaches. However, we can go back to such data, the location, through permit information. So every source of air pollution, pretty much every source of air pollution or equipment air pollution located within the air basin has to acquire permits from AQMD, and then we have the information of such data, and then we plan is go back to such information to identify the sources of emissions more accurately. And then another thing is warehouse has been the concern of many communities, and then how to, and then part of the plan to improve the cargo truck or heavy duty trucks associated with goods movement is one is of course warehouse location itself, and then the other is truck stops located along the freeways. And then such information is in a process of being incorporated into emission inventory as well. With this emission data, so the purpose of developing all this emission data is also to estimate the impact of these emissions into air quality, and then of course to human health. And then to do so, we have to utilize numerical modeling. And then the model that the AQMD uses primarily for these types of emission analysis is called the CMAQ model. But then here, so it's community multi-scale air quality model. But then basis of this modeling is kind of graphically illustrated in this slides. So what you see in the previous slides, that was emission, but very similarly, it is kind of a 2D shape of map. You can see the concentration map. But to do so, what you need to is what we discussed as the all types of emissions. And then you have to calculate how much airflow bring those pollutants into this calculation domain and goes out. And then it is not just this kind of mechanical transport, but also this solar radiation, and then humidity, cloud, and then temperature, etc., promotes chemical reactions, and the chemical reactions has to be captured properly. So this type of calculation is being done through the supercomputer or Linux, the cluster computers. It takes like thousands of hours to complete this type of calculation with a supercomputer. And to provide meteorological condition, so weather information, we all know there is weather station. Even anybody has backyard weather station, but there are airports that are more reliable sources of meteorological data. But those informations are location by location. When you calculate this type of numerical modeling based the exposure or concentration, you need a huge area that's uniformly covering your analysis domain. That's kind of, this is one graphical illustration of how large or what areas need to be incorporated in eventually to get this tiny little small, this air basin wide the concentration prediction or exposure prediction. And then the model we are using is WRF. It's called the Weather and Forecast Research, which is pretty much a state-of-the-art model. Most of the research communities, even National Weather Service, and then NOAA, NCA, all of those agencies using. And then we do extensive evaluation how well the model performs. For example, these are one of the examples that the temperature predictions per month, how the model predicted temperature versus the monitored, measured temperature look like. So it's never perfect. If I shows the model perfectly reproduce measurement, that means I'm lying. So it's expected to have a little bit discrepancy because modeled world is not same as the real world. But then generally the model performance is fairly good. And this is windrows that the model estimated wind direction, the prevailing wind coming from the west, and then measured wind direction also showing prevailing wind coming from the west. So we're pretty confident we perform the state of the science modeling and emissions inventory development here. And this is another map of the areas that we perform this exposure analysis. This red grid is the modeling grid that used in the MATES 4 analysis. That was 2 kilometer by 2 kilometer. This is specific, the exposure analysis was conducted using ChemX model that is called Comprehensive Air Quality Model Extension. And then through all this information and data developed by many steps for over multiple years, and then gigabytes or terabytes of the data going into it, and then you basically eventually use this equation, basically your concentration, you multiply it with the risk factors and come up with the exposure estimate. This type of maps you have seen in our previous presentations that given by AQMD staff. So those identified some of the hotspots near the ports. It's a higher exposure due to the large diesel PM. But allow me to make a comment here that these are again 4 or 5 year old estimate, and then we are conducting the MATES 5 analysis that has a different emissions inventory. And then this just the same information, but then what this highlights is one is concentration itself, but the other is the risk factor that's basically being developed by OEHA and the ARB jointly, and then depending on risk factors, the exposure estimation can be different, but the most updated exposure, most updated risk factors will be used in our next round of analysis as well. So, so primarily we're doing the modeling of criteria pollutants, but then again for exposure analysis we do include toxic air contaminants as well. And then we step still diligently improving our the capability to simulate or to model this type of concentration exposure analysis more accurately. One of the ways we are doing is we are not just working by ourselves, we working collaboratively with other leading agencies and laboratories in the nation, and in a sense even in the world, because the satellite data we're using is European Satellite Agency's data. So for example, this is specifically a NASA Jet Propulsion Laboratory, or NOAA, National Oceanic and Atmospheric Administration. We collaboratively working with them to get better, more state-of-the-art data, and then to improve our modeling. And this is just one specific example that we're trying to do to improve kind of over the transport over the Pacific. So this kind of this is general wrapping up my presentation here. And actually, we are going to defer questions to the end of the presentation, unless you really have some really immediate the question. Then you have the question that needs to be answered immediately. Okay, then we will proceed.
So I just want to take a moment to let the two additional technical advisory group members introduce themselves, and I have a couple folks participating by webcast as well. So Jesse, go ahead.
Jesse Marquez, Coalition for a Safe Environment in Wilmington.
Ryan Sinclair, Loma Linda University, for the Muscogee community.
Great. I do want to mention that we have Ken Davidson from the US EPA also joining us by webcast. And unfortunately, Jill Johnston from USC was not able to participate. She's actually out of the country. But one of her colleagues, Wendy Gutschow, is watching the meeting on her behalf.
That would be desirable. Is that okay with you? Hope that's okay with you.
Well, actually, there's a couple of important issues regarding weather that impacts the harbor. I'm not sure how extensive it is, but we have atmospheric inversion layers, which means the atmosphere actually comes down, therefore it concentrates. And I want to know, how does your modeling account for that? Or can it be programmed for those communities that would have that situation occur?
So I will answer this question quickly, but anyway, the atmospheric inversion layer, or in further inland community, it's more like atmospheric boundary layer or mixed layer. That is well predicted by the meteorological model, WRF model, weather research and forecast model. That's a three-dimensional. One of the slides I show, it starts with almost a half of the United States and then nested down to smaller domain that covers our basin. But that's a three-dimensional, so meaning that it starts from the surface level all the way to go to the tropopause, the 50 millibar level, or actually past the tropopause and then extend a little bit to stratopause. And then this atmospheric, this inversion layer or boundary layer is a part of this vertical structure that atmosphere has. And then inversion layer does captured by, simulated by this model. And then some of the measurement we have located in Los Angeles airport, and then some more inland sites such as near Moreno Valley or Ontario airport also measure the vertical structure as well. So. So here, so the suggestion is, since Jesse started the question, so we go ahead the questions from the committee members, and then the mic will open up to the public, and at the end of the presentation, at the end of all the three presentations. So anybody else in the committee? Yes, please.
I think this might just be a quick one, but I noticed that on the MATES maps for the different sources, the scale was different for each one. And it actually differs from a factor of 10, going from 10,000 all the way down to 1,000. Is it possible to get those maps so they're using the same scale?
Yes, it is possible, but the reason it's presented in that way is, as you notice, it's so different scale. So if you fix the scale, you would not be able to see spatial variation. But then the pie chart we provided during the CSC meetings kind of compares source by source. For example, on-road point area and then off-road. So that gives what the magnitude that each source contributes differently.
The pie chart is based on a regional
Yeah.
inventory.
Regional-
I think the point is if there's a way to help communities and everybody understand the differences at the community level, and maybe the MATES maps are one way to do that, or having that pie chart, if it can get refined down to the community level, because right now it's a little bit hard to do comparisons across the different source types.
That's what we included in. Yeah, the pie chart were included in the CSC number 3 meetings, right? So, so the very first meeting we also included each community. The presentations we given at the CSC meetings has the slides that showing the pie chart, the contribution of different categories, and also this the meeting the number 3 that we have this month has another slides that the pie chart that's showing different categories and even different pollutants that contributing to the total the exposure risk. At the community level, yes, at the community level. Jesse? Oh, okay, Jesse.
Communities often we need to know on a little bit more micro scale what's happening with weather. And I'm going to give you an example. One time, ConocoPhillips oil refinery was flaring. And so I was taking photos just west of it, up a little hill, and the wind direction was going north by northeast. That's 1 o'clock. Approximately 4:30-ish, I was at the exact same spot doing the same thing, taking photos again, and the wind had shifted from north to actually south by southeast. Now, normally that wouldn't seem like no big deal, except for if there is a emission, it's a very toxic one or a life-threatening one, knowing in advance that that will happen. I don't know if it happens every day. I don't know if it happened to be, that season. I don't know that. But if it's, say, hydrofluoric acid being released, and I have a 4 hours window knowing that, it might shift, and so the risk factor then increases knowing that as later in the day that wind is shifting. And if I look at one of your rose plumes, that doesn't tell me like on an 8-hour schedule or on a 24-hour schedule, yet it's critical for early warning and public notification, should we need to evacuate, or if I'm a COPD or a high risk respiratory type problem, then again I can close my windows, shelter in place, turn off my HVAC system there. And that's the type of information that we need to know.
So I think there are 2 folds in your comments. So let me first start with the meteorology first. So here in this Los Angeles air basin, as you observe, the wind direction shifts. And then there is always kind of prevailing wind directions, mostly in climatological sense during daytime. The wind's mostly coming, in general sense, wind mostly coming from the ocean to the land. And then during nighttime, the airflow goes from the land to the ocean direction. But that is in kind of climatological sense. When you make the average of when you track every hour wind, and then in a year you get 8,640 data point, and then you analyze which windage is coming at every hour, then you can pretty much see the patterns. Morning time is coming from the sea, evening time is coming from the other side. But then that leaves what's the capability. So that kind of the wind patterns are captured in the monitors as you can observe. You go out there, you can observe how it is changed. So same data will be recorded in the wind anemometers. But then when it comes to modeling, so the approach is that we have to see more like what model can do. So that type of, the currently numerical model does not see really human to human scale or one person scale. That's in the future, hopefully that's the case. But then still what we see is more like average sense. Okay, this is this facility, and then here is the flare coming out, and then with even over a year, where the most of those going type of things. So the weather model we are using, or even weather model, same model the National Weather Service use, does predict wind patterns in hourly scale. I would not go less than, so I do not go like minute interval or half of an hour interval, but as long as it is hourly data, it is forecast is more or less capturing, but I would not say that's perfect. Again, the modeling world and real world are different. So the quick answer, I'm no, sorry, this was not a quick answer, but then the model does capture the variations of wind every hour, every different location, and different height. That's the weather part of the answer to your question. But I believe that the second part of your question is also sort of emergency responses part, so which I will have the Dr. Jason Lowe take over.
Yeah, so Sang-Mi did a good job about the meteorology, and I just want to comment about timescale. So I think what the modeling does is, as Sang-Mi pointed out, it takes kind of that aggregate average of the meteorology data, so it can kind of predict a general exposure. And that's very important when you're looking at long-term exposure. So you're looking at importance for the more carcinogenic compounds, things that are going to cause harm over a long period of time. In the case that you're presenting, which is HF or any other pollutant that can cause acute health conditions, that's where we would look to the real-time monitoring of the wind conditions to be able to help out with doing an assessment of what the next actions are.
Well then, because we are EJ communities that can be seriously impacted, it's important for us to also have maps models showing what it is on a 24-hour scale, on an 8-hour scale, because how can we prepare for something when we really don't understand it, you know? Having that extra few hours warning, you know, is valuable for the community to know, because if I live in that area, then, you know, I'm representing my community. Others are representing Muscovy, others represent East LA. You know, it's important to know what things on a micro scale. When you average things out over a long distance, that's great, but, you know, I'll be dead by that time. You know, so it's more important to us have things on a micro scale so that, you know, I can understand that. Because, give you another example, I'm preparing a Wilmington emergency preparedness plan and the emergency evacuation maps. Okay, so in the process of me, I've learned quite a bit in that process, but you know, I also know that minutes can be critical depending on what the circumstance is, and not having a map showing that compounds it. You know, if you can work with us in our communities to prepare something on a 24-hour scale, 8-hour scale, so we know there's a critical time element, then that's important for us to know.
Right, and definitely those comments are taken, and since there's the more immediate part, I mean, we're looking both, when we're looking to like the monitoring plans, for example, that will lend more towards itself, towards that more real-time information and feedback. I think that discussion of timescales, and that's definitely something that we're considering as part of our community air monitoring portion of that. So with that, we've got a couple more people, so maybe we should move on.
A quick question that I think is additional rather. So I think that the problem of variable winds, you know, it's definitely very important. I just wanted to add that on the monitoring side, whenever we are evaluating potential emissions from, let's say, a refinery or from a kind of high elevation, we do have access to a vertical wind profile instrument, a LiDAR, that basically tells you how the wind changes with altitude, right? And we have noticed that, you know, you cannot definitely rely only on ground-based information to kind of understand where the plume is going. So that's, you know, we have that part covered, but, you know, that is relevant to the monitoring presentation that Dr. Pak Bin will give later on.
Okay, so with that, let's move on to the next question. Rafael?
Thank you. So, with regards to the on-road source emissions, so can you explain further where the information is obtained from, and what type of like traffic studies, information gathered from, let's say, agencies like Caltrans that do continuous monitoring of highway traffic, and then for your mileage travel data, if you do or can partner with insurance companies that collect actually the very specific data that's reported every year, that they require to report every year on how much mileage people drive, and then the distance usually traveled to work.
Mhm. That's a good comment. Kind of troubles me is how would those data will be publicly available data. But anyway, let me go back to the first part of your question. What are the sources of data for on-road mobile source emissions? So there are three big parts, but I think the most important part, judging from your question is, listening to your question is, there's vehicle activity data that includes the number of vehicles, types of vehicles, and then the miles that individual vehicle travels, and then where those activity occur, coming from the SCAQ's, Southern California Association Government planning part. So similar to us, they are required to perform regional transportation plan every 4 years. So currently, SCAQ is preparing 2020 RTP, and then they are the official, the Metropolitan Planning Organization, so to track where those vehicle activities occur within the basin. So we are actually required to coordinate with them and then use those data, since those are officially recognized by EPA and then federal highway authorities. Second part is, additional to that, is the emission factor data. As mentioned, it is coming from ARB's MFAC data, and then it has emission factors, all different types of vehicles and load factors, activities, and such information are based on the lab test or field test, actually people going out and measure emissions from individual vehicles, and then compiled such information compiled into this emission model. And then the weather information, like the temperature, relative humidity, we use a sort of a hybrid approach to combine the measured data with mesoscale modeling information. But then having said that, again, your suggestion on this getting more accurate VMT is the good question. Oh, so Jason is going to help me.
So yeah, no, I think that's a good idea, and I think there's a couple of other air districts that are also looking into that. In fact, Joe Kay and I had a conversation with a third party that is providing similar types of data, but it's not quite exactly what we're looking for as far as meeting the kind of that local goal. So we're trying to see if we can work with them on a project, but it just kind of depends on what they come up with. But it is something that we're looking at as other third-party vendors that may have similar type of information. Other information that we can use is the Department of Transportation has also information with regards to highway vehicles that travel on it, and also what's important to us, as Sanghimi had mentioned as part of the modeling, but also would be important as part of our interpretation of our monitoring data or our emissions reduction plans, would be the types of vehicles. So on the highways, there's called the PEM system, which does distinguish between light duty and heavy duty vehicles, and that is also another source of information. The only disadvantage of that information is that it tends to lag. It takes several years sometimes to get that information, but at least it can give us a baseline to look at, and then as we move forward with the program, we'll be able to do some comparisons or maybe work with them to see if we can get those data sets faster.
But as you can imagine, the information that's currently being used is actually several years old as well, from what I understand. I mean, that's what the SCAG data is quite old. As you are aware of it almost on a daily basis, especially given that we operate the ports of LA and ports of Long Beach, the amount of inventory can fluctuate drastically, from one month to the next, from one day to the next. And so, in communities like East LA, Boyle Heights, and then the Wilmington areas, to a lesser extent, but when you have a large cancer risk area like we do, and most of it is almost evenly split between, let's say, rail traffic and on-road traffic, it becomes very vital that we get really good information, so that way we can properly assess the really the impacts to the community. So that's why, if, for instance, on a daily basis, we have traffic studies and traffic patterns and stuff, and then we see things like SIG alerts and where we have a high congestion of traffic flowing in and out of the freeways at various times of the day. Perhaps some of this information can be obtained and utilized, especially when we see large amounts of cargo flowing into the ports, because you have shipping data and whatnot. A lot of this can be correlated, hopefully, within the model itself.
I'd like to clarify that we already utilize such information. So as I presented in my, included in my slides, we're utilizing this traffic sensor data. That's also, Jason pointed out, that is part of Caltrans PAMS data, and also WIM, the weight in motion data. So that does record the amount of traffic at each major freeways and the major surface streets, and that information is used to allocate emissions correctly, actually. So that does reflect the month-to-month variation or day-to-day variation, or even hour-to-hour variation. So we have some confidence in that data, actually. And next question, Ryan, please.
I had a question about the slides regarding the diesel PM emissions from on-road. I'm thinking about this in terms of idling diesel versus diesel trucks, idling diesel semi trucks versus semi trucks accelerating versus semi trucks just traveling, cruising at high speeds. And I'm looking at the maps, in particular the second map in when it talks about diesel PM emissions from on-road. And I don't know, it looks like the red, the highest points are along the roads that are where the semis are actually on the road. They're not idling around in the warehouses and such things. And one of the concerns of the communities in Muscoy is definitely that the semi trucks are coming and idling. And maybe you could give me some knowledge, some air quality 101, outdoor air quality 101 on how is PM 2.5 released in terms of is most of it released when trucks are idling, or most of it released when they're going at high speeds? I know that Sunny had just showed me what was it, the NOx is during high speed instead of low speed. But for PM 2.5, what's the trend there?
So PM 2.5, unlike NOx, has two different mechanisms to emit into atmosphere. One is exhaust emission, which in that case it's similar to NOx, but the other one is the wear and tear that comes from brake use, or that comes from the dust on the road. So that's proportional to, the second part is proportional to VMT, the miles the vehicle travels. So it's, but then the first part, exhaust emission, is more like, the questions raised, like related with idling or vehicle speed. But then in general, emissions has this speed correction function. So when you travel in optimum speed, let's say 40 to 60 mile range, 40 to 50 mile range, the emission is kind of lowest. If you are really going lower speed, like 5 mile per hour, the emission would be as high as you travel like 80 miles per hour. So this is sort of roughly defined U curve. So speed is in a sense incorporated into the emission calculation. Having said that, idling is kind of a little bit different category because in that case, a truck is not moving. So strictly speaking, that is not part of this moving the on-road emissions. But then what we try to reserve or improve is by incorporating the locations of warehouses and then truck stops. We associate those areas with sort of idling or truck refrigerate unit emissions there. Already some of those are incorporated in the current emission inventory that we use, but then we are trying to further improve for the communities like San Bernardino, Moscow has large areas occupied by warehouses. So we're going into further micro scale to capture those areas accurately and reflect it. I think we have to move on to next presentation. We have 3 presentations and got only 1 covered, and that's already 70 minutes past. Would it be okay? Maybe we catch up later. Thank you. Okay. So next presentation is going to be. It might take us more than 10 minutes of questions and answers. Sure, and then all the staff, yes, thank you. All staff will remain here and make ourselves available to answer all the concerns and questions you have after the meeting, even after the meeting. So next presentation will be by Dr. Payam Pakbin regarding traditional and advanced air monitoring technologies and advantages and limitations. This way. Wait. Can I have mouse, please?
Yes.
Okay.
Thank you, everyone. So again, I'm Payam Pakbin. I'm a program supervisor for special monitoring in the Advanced Monitoring Technologies unit. I'm going to try to go a little bit faster through these slides so we allow some more time for the discussions. So the monitoring in general enhances our understanding on emission sources, on pollutants of interest, and the levels of pollutants of interest in different communities. It also helps us to track the effectiveness of emission reduction strategies and assess the human exposure. It's basically a source of information that helps us to effectively improve and support the air pollution control programs and emission reduction plans. In general, air monitoring is just one of the many tools that is available to the decision makers to make good decisions and manage effectively and improve the air quality. Generally speaking, air monitoring in the context of AB 617 can help us to improve estimates of community level exposures. They can assist in improving facility leak detection capabilities, validate emission inventories, and inform future policy and rule development, and ultimately guide the incentive fundings. So to design this air monitoring systems in each of the communities, 617 communities, we are in the process of developing community air monitoring plans. Some of the major steps in this process is to review the past and existing community monitoring campaigns and programs and look at the lessons learned from all of those monitoring that already has been done. Or even some of the monitoring that is planned to be done in near future under several different rules that we have. It also, considering that information, it recommends for additional monitoring in those communities. And we're trying to use mostly the advanced monitoring technologies. The 617 monitoring does not have to be EPA approved monitoring. This allows us to use some research grade advanced monitoring techniques that allow for example, much higher time resolution data. And we're also working with the steering community members to conduct this monitoring in partnership with the communities. And ultimately, all this data has to be provided to the community in a proper way and put into the context. So generally speaking, the goals of community air monitoring is to enhance our understanding of pollution sources and their impacts within each of those communities, and also to support the implementation of emission reduction plans. Generally speaking, when we talk about air monitoring, we're looking at two different categories of air pollutants. One of them is the criteria pollutants. These are some of the pollutants for which we already have federal or state standards. They mostly their impact mostly is like regional or local scale. And then there are another category of air pollutants are the air toxics. These impact mostly in the local scale or in the source specific scale, for example, impacting the areas neighboring source of emission. Both of them can cause health impacts, and both of them are covered under their monitoring programs. And when it comes to the local scale and community scale monitoring, the air toxics are becoming more and more relevant. So we have lots of monitoring tools in our hand when it comes to developing the monitoring systems for these communities. These are some rough categories. Some of those are regulatory monitoring instruments. We do have mobile platforms, and then a newer, more advanced technology is the optical remote sensing, and also the low-cost sensor networks. That are excellent tool to engage the communities, and also very good as an educational tool. So each of these monitoring categories have lots of advantages and disadvantages. Here, I'm only going to talk about how the data will be available to the communities and to the public. So traditional monitoring, those are, for example, the monitors that we have in our monitoring network, or some of the little bit more advanced, for example, continuous EPA-approved monitors. Some of these are time integrated, meaning that the samples have to be taken on a filter mostly for 24 hours and taken to the lab to do chemical analysis. So the data is not available right away. It takes some time to process the data, to do the chemical analysis. And the data will be provided in a later time as a scientific report or summary. We do have some continuous and continuous real-time monitors as well, so the data could be available in near real-time display, like for example the 617 data platforms that we're also working on. The mobile platforms, there are so many different kinds of them. I'm going to show those, but generally speaking, if the mobile platform is intended to take measurements while driving around and doing surveys of a large area, it requires some monitors that can measure the pollutants continuously and in a very high time resolution. These could be, the data actually could be transmitted to us in real time. However, because the platform is moving around, it requires our staff scientists to work on the data, process that, and generate the reports and summaries. So the data would not be available right away. We have to work on it, interpret the data, and then provide graphical map data or scientific reports and summaries. The next category, the optical remote sensing. Again, there's many different ways of using this, but generally speaking, these are continuous, high time resolution. The data could be provided in near real-time data display, but in case of a specific incident, we do have to look at the data more closely and again develop reports about those incidents. Finally, the low-cost sensors, the data is available continuously and real-time. It can provide that data in real-time to the communities and provide a better access to the data. However, they're limited in the type of pollutants that they can measure. And also the air quality and the air quality data, the quality of the data is not as good as the other monitors. So I'm going to provide some examples for each of these monitoring techniques and technologies. These are not all the things that we do, but I thought these are some of the examples that are more relevant to the three communities for the first year. This is the regulatory monitoring that we do. This is our monitoring network that we have. The purpose of the monitoring is to support regulatory programs, assess regional air quality, and track progress, and also as part of a compliance monitoring. They use EPA-approved monitors and equipment, and in some cases, the data is time integrated, and in some cases, they're real-time and continuous. I want to mention that at each of the first year 617 communities, we already have one monitoring station that's been operating for a long time. This is another example. Sangmi already explained our MATES study, so I'm not going to go through it for too long. But this is one of the examples that we used a suite of different type of regulatory and EPA-approved monitors to measure both criteria pollutants and air toxics. As Sangmi mentioned, one of the biggest takeaways from this study was the fact that diesel particulate matter accounted for 2/3 of the total air toxics cancer risk in our air basin. I have to also mention that this is the basin-wide average, and in fact, the DPM impact in the three communities were a little bit higher than that. And then black carbon measurement was used as a surrogate for the diesel PM. And because diesel PM is one of the main focuses of all the three communities for 617, we're going to do some black carbon measurements. So this is very relevant. This is another example specifically doing measurements at the source. This particular example is actually part of the MATES-4 study, which was conducted in 2014. And I forgot to mention that we're currently doing our MATES-5 study. The data is not available yet. Just like I said, these require some chemical analysis and the staff scientists to work on the data, to interpret the data. But this MATES-5 study, for the first time, we're also using all sorts of advanced monitoring techniques. These include flight-based monitoring, mobile platforms, optical remote sensing, and sensor networks. So this particular example is part of MATES-4. So back in 2013, we deployed monitors to measure ultrafine particles and black carbon. Both of them are good tracers for diesel particulate matter. The deployment was at the San Bernardino rail yard. And as you can see, this is just one of the graphs from the study that shows the black carbon was in fact elevated at these sites. Another example on using these traditional methods for source monitoring is our efforts in city of Paramount. So we measured some elevated levels of hexavalent chromium, which is a toxic, it's a metal toxic. So we deployed a series of monitors to collect samples. These are 24-hour samples that again have to be taken to the lab for chemical analysis. This was in an area with many metal processing facilities in proximity of each other. So just finding the main sources that contributed to that elevated level of Chrome 6 is very difficult. So as you can see, we kept adjusting our monitoring. Some of the monitors were moved around. The monitoring was actually expanded. And since it's starting from October 2016, as of February 1st of this year, we collected and processed over 4,800 samples. This is very labor intensive and very costly as well, but this is the most effective way using a traditional monitor to look at to find out and perform like some sort of investigative monitoring. So moving on to the mobile air monitoring platforms, usually the main purpose is to identify unknown sources of emissions. So again, like an investigative type of monitoring, identify hotspots and inform monitoring planning. And the main advantage is it allows us to cover a much larger area. This is very important when it comes to 617 monitoring, because the communities in our basin are actually very large areas. The mobile platforms are different. Within this category, we have different categories of mobile platforms. Basically, one of them is mobile stationary stations. These are basically a trailer that we can that could be equipped with all sorts of different monitors. These are not meant to take measurements while moving. So like we basically have to bring it to a location and take measurements, but it provides the flexibility that you can move it around and adjust your monitoring. We currently are working on equipping several trailers. Some of them are focused for VOC measurements. Some of them are more focused on criteria pollutants or particle-based air toxics like metals. And then we have mobile laboratories. These are meant to take mobile surveys. So they require like monitors that are very high time resolution, because the measurements are taken while the platform is moving around. And finally, the flux sense, which is an optical remote sensing, and it's the most effective way to measure for the VOC measurements. This is one of the examples. This is our latest mobile platform. It has different monitors for measurement of black carbon and some of the criteria pollutants. This same van, this SUV is actually parked outside. So after the tour of the lab, you're more than welcome to take a look at it. We're going to have our staff to answer any question you have. This is another effort using mobile platforms to investigate, to take continuous measurements of Chrome 6. This is research grade. We did it in collaboration with Aerodyne Research and DRI. This is geared towards measurement of Chrome 6 as well as total metals, but the novel part of this project is to be able to measure Chrome 6 in continuously. So it would help us in investigative efforts when it comes to the toxic metals. This is our FluxSense optical remote sensing van. It has several different monitors. All of them use optical remote sensing. Some of them rely on the sunlight as the light source, and some of them generate their own source of light, so they can take some of the measurements both during daytime and nighttime. So I'm going to show you some examples about our efforts using this FluxSense van. This is one example showing our measurements around the refinery. So along with the wind data, we can pinpoint maybe where the source of those emissions are. And this would definitely help with the detection of the leaks, which is otherwise is very difficult to detect. Here's some of the results from one of the studies we did measuring the emissions from the refineries. All the major refineries in our basin were included in this study. As you can see, like there may be some discrepancy between the measured and reported inventory emissions from for the VOCs. This is partly because these VOCs are emitted as fugitive emissions. These are from small leaks, but in a very large facility, it adds up. However, like the NO2 and SO2, the measurement and the inventory actually are in very good agreement. This is partly because these are mostly stack emissions, so we have a much better understanding of them. They're taking measurements at the stack. I have to mention that this study is like there are some uncertainties. These measurements were done only for a short period of time. So like depending on the operation, this might not give you the overall picture, but this is a very good starting point, and it's going to guide us in our future efforts. Another example, using the FluxSense van, this time to evaluate the community impact from the refinery. This is one example. I think this is preliminary data. This is a survey that we did in the community downwind of the refinery to look at the hotspots. And again, using the wind data, it's possible to backtrack and see where the possible source of those elevated levels are. Another example is looking at the smaller sources. These smaller sources maybe the emissions from these smaller sources may be smaller than much larger sources like refineries, but there are thousands of these oil wells in our district. So just going and taking measurements using traditional monitoring, it's very time consuming. So this type of mobile surveys is excellent tool to look at maybe the high emitter oil wells or look at the problems. In this particular case, for example, we saw high levels of benzene at one of the oil wells. I want to add that this survey, for example, led to further investigation by our compliance team that confirmed this with flare camera, and it was actually linked to a vent of one of the tanks at this facility. Another example is looking at the storage tank emissions. This is a very good example showing that we use different tools to confirm and evaluate our measurements. For example, on the left, you can see on the top left side, you can see some of the measurements of methane that we did using a LICOR analyzer, which was mounted on that SUV that's driving behind the FluxSense van. We also had like a low-cost sensor. These are not good for quantifying the VOC levels, but they're excellent tools to give us some sort of notification, first notification that there's an elevated levels of VOC. So we can go and deploy like more sophisticated monitors to quantify those levels. And then finally, the FluxSense van using a DOAS system is measured at the same time the benzene levels, and all of those were confirmed using a flare camera as well. So this study is ongoing. It began back in 2013. Again, these mobile surveys require a very long time to process the data, to interpret the data. However, some of our earlier studies are already finalized, and you can find the final reports on these three particular studies. One was on emissions from large refineries, from a small point source like oil wells and gas stations, and the ports. Another example is like looking at the community impact. So these surveys gives us the whole story. We can do back trajectory analysis to look where the sources are, as well as how they may impact the communities. Another example is looking at the ship emissions using the FluxSense van that was tracked back to the ships that were harbored. The same optical remote sensing monitor could be measuring, like, for example, the H2S levels from the ships for compliance purposes, for example. And then some other monitoring techniques that we can use is, like, for example, flight-based measurements. These are excellent tools to cover a very large area. It takes a very long time to process the data, obviously, but it can guide us in focusing or, for example, deploying our mobile monitors to a specific source. And finally, our low-cost sensor networks. These are some examples for the community deployments. These are sensors that in a very dense network within a community. One example of it is our network in Seal Beach. This is a community that is near a very congested area of 405 and 710 and very close to Port of Long Beach, as well as Long Beach Airport. And it would help us to assess the spatial and temporal variability and identify potential nearby PM sources. And finally, when it comes to designing our monitoring systems for each of the communities, this is very important to understand that this is a balancing act. There are many factors when it comes to choosing the appropriate monitoring technology. One of them is the data quality, and one of them is the cost, as well as how much of an area you can cover. For example, the ambient air monitoring network that we have, or the type of source compliance monitoring that we do, produces very high quality data, but it's very costly and it cannot cover a very large area. However, some of the supplemental and investigative air monitoring that we do, which doesn't have to be EPA approved monitors, gives us that opportunity to maybe cover a larger area and bring down the cost, but at the expense of data quality also being compromised just a little. And then it comes to mobile surveys that, because we can cover a larger area, would be more costly. It would be more cost effective, and it can cover a much larger area. But the problem is it gives you a picture at the time that that survey was taken. These are not ongoing monitoring. And finally, low-cost sensors. Obviously, there's some problems with the data quality, but it gives us the opportunity to expand that network and take the measurements in a very high density and cover like a larger area in each of the communities. So to wrap it up, we have in order to develop those monitoring plans, in the next CSC meetings, we're going to continue our discussion about defining goals and objectives of air monitoring. And that would help us to select and recommend appropriate monitoring technologies for each of the communities or each of the monitoring purposes within those communities. We have to take this to our board in April to make purchases of those monitors. And then our work will start. In fact, it has already started working on developing community air monitoring plans. Those plans have to be finalized and submitted to CARB by May 1st this year. And finally, we're going to begin air monitoring in the priority areas by July 1st, 2019.
So, Payam, thanks for the presentation. So the next presentation is about overview of AQMD's laboratory capability, which is very closely related with this monitoring this presentation. So we'll go over with the next presentation first and then get questions afterwards. So the next presenter is Dr. Aaron Katzenstein. Please. Let me change it.
Good morning. I'm just going to start off with a kind of a 100-foot view of our laboratory. So the picture on our right is one small picture of our 23,000 square foot laboratory. We've got around 50 staff, plus or minus 3 every week. We have students come and go every week. But right now we have around 50 scientific instruments. And we're currently established with 3 groups. So the first group, aerosol analysis, is focused on particulate matter analysis. So they look at the chemical speciation of particulate matter. We also do microscopy analysis, so asbestos and anything that falls out onto a sample plate we can look at with the aerosol group. The second group, ambient VOC and toxics, is more gas related. So those are the gaseous samples that we collect, say, at a coastal odor event, or even at our monitoring stations to look at the VOC content or the aldehyde content of the air sample. We also have a compliance group that's largely focused on enforcing our VOC regulations that we have on the books here at AQMD. They also do source test sample analysis for things like refineries or any stack emissions, things like that. And then we have a new group called Advanced Spectrometry, and we actually just posted the supervisor position for this job yesterday. So if anyone is interested or know of anyone that might be interested in basically conducting mobile mass spectrometry measurements, so the instrument we're going to purchase for this group is a proton transfer mass spec, and that's going to give us real-time VOC levels down to some parts per trillion levels. A large focus of what we do in the laboratory is based on the 40 monitoring stations we have in our basin, and these are largely dictated by the EPA program. So the PM 2.5 program measures the 2.5 mass, fine particulate mass. So the samples come back to our lab. They're 24-hour average samples. We measure the mass in a temperature and humidity controlled room. We have the PAMS network, which is the photochemical air monitoring station program, which is the ozone, NOx, and hydrocarbons. So when you look at the ozone levels on our website, the real-time levels, they often come from the PAMS network. We have the NATS program, which is the National Ambient Toxic Trends Station. So that's kind of like a MATES program, but continuous year over year for 2 stations. And we also have the Chemical Speciation Network. So that looks at the chemical composition of the particulate matter here in the basin. Some of the other programs I mentioned earlier, we have asbestos programs, we have VOCs, we have source test. And then as Sangmi and Payam mentioned, we also have a lot of special studies like the MATES program. We have MATES 5 going on right now. And we also have a lot of special studies like Paramount, Exide, things like that. So last year we had 18,000 samples received in the laboratory, and many of the samples require multiple analysis. So we did close to 38,000 separate analysis last year in the lab. So I want to focus on just 2 groups, the particulates and the VOC group. Just to give you an overview, we look at 3 sizes of particulate level in the laboratory. I've got the ultrafines, PM.01. We don't quite do those yet, but we'll look at PM 2.5, PM 10, and total suspended particulate. So that's anything that will go on the filter. We also look at fallout material too as part of the microscopy group. So our capabilities for the particulate matter samples, we can look at metals using inductively coupled mass spectrometry, X-ray fluorescence. We look at hexavalent chromium on these samples. We do the elemental carbon analysis, organic carbon analysis that's used for the diesel composition for MATES. We look at sulfates, nitrates, sea salts, things like that with ion chromatography. And this past year, we started looking at levoglucosan. So levoglucosan is a sugar that's formed from the combustion of cellulose, so wood smoke. And we help tease out whether the EC composition is from diesel or from wood smoke with a levoglucosan marker. And just an overview of our PM 2.5 levels, this is from MATES 4. About 50% of our 2.5 is directly emitted, and about 50% is also secondarily formed in the atmosphere from gas to particle conversion. So I want to just focus real quick. A lot of the samples we receive from inspectors are swept samples. The question is, what's in this fallout material, say from an explosion of some sort, or is there metals being released past a fence line, or is this asbestos? These are a lot of the questions we get. So to answer these questions, we often deploy glass plates, and we look at the fallout material on the glass plates. We also just get, like I mentioned, floor sweeping samples, And so we have a variety of instruments we can use to look at these unknown particles. One being a microscope. So if you look on the bottom right, that's an example of an asbestos sample. We also have an electron microscope that's very useful for metals. And we can look at using the electron microscope, the metals essentially almost fluoresce under the microscope. And we can go through and have the microscope identify the metal composition and also the diameter, the size component. And then we take these samples, either fallout or the samples receive the particulate matter, and we can dissolve them in acid. And an example of the metals we look for using ICP-MS is listed here. We have a little bit more capability with the XRF, but we can generally go to lower levels with the ICP-MS on these samples. And going back to Pam had mentioned earlier, that a lot of this is very labor intensive. And so I wanted to show an example. This is for hexavalent chromium. So a lot of the sample prep work begins before the sample is collected. We have to prep the samples, make sure the sample is blanked correctly, there's no contamination in the sample. Then it gets allocated to the field. There's a chain of custody involved in the whole process. The samplers have to be calibrated, make sure they're properly sighted. We have meteorology involved with them. And then the samples get recovered in a short time period. Chain of custody is following the sample the whole time. The sample then has to be received, placed into a freezer or refrigerator, and then appropriate analysis is then conducted. So it takes some time, as Pam mentioned, for laboratory analysis. And just an example of the gas samples, on the bottom right, you can see those kind of shiny bulbs sitting there, and those are 6-liter, essentially SUMA canisters. And they're on the analysis rack right now. So then we essentially freeze out the gas sample. So all the oxygen and nitrogen will pass through the frozen loop, and all the impurities, the VOCs, will be trapped and concentrated. And then what we often use is either GCFID or GC mass spec to do the analysis. We also can do sulfur samples using Tedlar bags. And the canisters, if they're silica lined, we can use sulfur for those. And we also do carbonyls on DNPH cartridges. So this is an example of many of the compounds we can look for. This is the TO15 list. This doesn't include a lot of the hydrocarbons we also look for. So a lot of these are toxic, some are refrigerants, and some are ozone precursors here. And with that, I'll conclude my presentation.
Thank you, Aaron. Now we open up questions to the committee members, advisory group members. Any questions? So, Udok.
Thank you. Couple questions on one of, air emissions is infrequent and sporadic, and we get these time snaps like the San Bernardino rail line that show the PM or diesel levels, or the oil well that had higher benzene levels in Signal Hill. What, I guess, is the process looking towards increasing the frequency of testing? Because I think I've looked at many facility ID emissions inventories, and there's some readings for 2007, none until 2012. Is going forward only about the MATE studies for these type of samples, or is our goal to get to more frequency of testing? I'm assuming that's a financial constraint as well.
So to answer your question, yes, this is supposed to be a enhancement of what's already been done, and also a change, because the MATES study has been mentioned multiple times before. That's looking at regional air toxics and regional kind of exposure. So what we're trying to look at through the AB 617 program specifically is to look at the priority communities and look at the priority concerns of those communities and find the most appropriate tool. And as Paya mentioned, monitoring is one of those tools, but there are are many other tools that we have available, whether it be community partnerships, whether it be partnerships with other agencies, our compliance division, rules. So monitoring is to provide that information to help support some of those other actions that are more enforceable and actually lead to emissions reductions. So we are looking at doing more measurements in the priority communities and either more frequency or continuous, depending on what the situation is. One point I wanted to make was Pam showed that that graph of Paramount, how we started off with 6 samplers, and because we saw the high levels and the concerning levels of hexavalent chromium, we quickly expanded. And that's one of the things that a community monitoring plan, it's going to probably be left open for that flexibility to say, here's our initial set of what we plan on doing. But that can quickly change if there's information from the monitoring that would warrant either further or less action. So,
And then one follow-up, I guess, thinking of the end in mind of where we're going here. So for each of our communities, we're going to tee up 5 or 10 projects that are priority to the community, and then we're pitching it to the state to see if they'll fund it, or there's a bucket of money that we're waiting for the state to decide what's going to get funded or not. Is that where we're going?
So yes, good question. So basically, we have to put together the emission reduction plans, and in addition to that, also an air monitoring plans. Now, even though in some ways they have different requirements in statute, what we are trying to do is really integrate them because we want to use monitoring as a tool to support the emission reduction plans. As far as the specific process, again, what's required by statute is our board has to approve before September 27th of this year. So that's the deadline that we're aiming for. So basically, it has to be approved by our board, and then subsequently, I believe within 60 days, approved by the Air Resources Board. As far as the question of funding, so that's just the approval of the plans. As far specifically of the emission reduction plans, I believe the air monitoring plan does not require board approval. Okay. The board approval that Payam did mention was that we need to purchase some expensive equipment. That requires board approval. We can't sign those checks. So now, as far as the funding goes, we've gotten a sum of funding from the state for implementation of this program, including those equipment purchases, but also including staffing costs to be able to run this program. So that has already been allocated, if you will. I don't think we've actually gotten it yet. It's been allocated to us for this year, and then I believe it may have been allocated for one more year. But the specific distribution across the air districts, I don't know that has been determined. So the approvals of the plan in some ways the funding is not dependent on the approval of the plans, but our ability to execute it, of course, is dependent on getting that board approval. So we received 20 million, and that's across that's for the entire program. So all 3 communities, and any work that we need to do to prepare for the future years, the communities that will be designated in year 2, 3, and 4, and so on.
So next question, Raphael, please.
Thank you. So there was just a couple of, earlier in the presentation, I believe it was in the prior presentation, there was talk about black carbon. If you guys can clarify the distinction between black carbon and the PM2.5, the PM2.10, for those that just aren't familiar with it. Also, in the timeline, there was, because the April board meeting is coming up really quick, I'd like to know, I dare not say what equipment has been already chosen by AQMD staff, but what are you guys looking at to present to the board? Because I know, there's already a laundry list of equipment and whatnot that's been chosen for this particular program by the district staff. So if you guys can share that, so that way there's no duplicating of all that stuff. The other question that I had was, so it'll be important for because PM 2.5 emissions, especially in and around the various communities and whatnot, are the main pollutant sources for particular communities. And there's two major sources, from what I understand. Of course, you were mentioning the brake dust, and then the diesel particulates directly from the diesel exhaust that are coming from various sources. So it's my understanding that I guess there's some, equipment and whatnot that could be utilized, street sweepers in particular, that have been developed by various companies and stuff that can pick up a lot of this equipment in order to help reduce, as opposed to have traffic drive over it and readmit it into the area, thereby causing higher, incidences and probably readings to occur. The third part is, what has the district done in terms of communicating those levels to various cities and agencies that, let's say, do offer street sweeping and county maintenance and whatnot, and expressing to them that there's various pollutants out there. A lot of it's, deposited on the ground, because clearly, that's how your instruments and filtration and filters are collected, I guess. They're deposited somewhere. And then helping them understand how to deal with this particular disposal of that, because again, it's toxic waste now. And because it gets picked up and hopefully properly handled, how do we handle that? So, I'm hoping we're moving towards ultimately community action and cleanup in this whole process, because I guess that is the end goal, right? We're looking to clean up the communities, and so
Okay.
there you go.
Okay, so I will start the first part, and then either Payam or Jason can answer the other questions, such as equipment purchasing. So I'd like to start with this distinction between PM and then black carbon first, because that's also we received the questions through the webcast viewer, Wendy Gotcho, also asking diesel PM versus black carbon and then ultrafine particle. So I'd like to start that when we're talking about PM 2.5, it has many different chemical components in it. One of them is like something like black carbon, which is very similar to elemental carbon. There's organic carbon component and sulfate, nitrate, ammonium, and then the metal components or something like soil, the crustal materials we're talking. So the first part is relatively clear that BC or EC is a subset of the total PM 2.5. And then diesel PM is also a subset of PM 2.5. Diesel PM is defined as PM emitted from diesel exhaust. And then we also discussed this sources of directly emitted PM 2.5 as two forms. One is from exhaust, that's diesel PM part, and the other is an brake and tire wear and tear of the diesel, wear and tear of the vehicles. But then this resuspension of the PM particle PM, or even the brake wears, are kind of little different characteristics from the diesel exhaust PM. Those contains more highly the crustal materials, could have the PM, but so I'm not discounting this street sweeper efforts. That could be the one area if it's identified as the one of the highest concern, that is relatively probably mechanism-wise simpler to implement. But then when we're talking about the cancer exposure, the risk, it's a diesel PM that coming from exhaust pipe is identified to have a higher contribution, probably that has more higher emission as well. So that control to that part could be many different forms, like a cleaner vehicle or implementing control technology on the heavy-duty trucks, such as diesel particulate filter, could be the ways to promote the cleaner trucks more. So so those will be, I guess, discussed ultimately in emissions, community emission reduction plan. And then now my answer is spilling over to Wendy's question about using BC as a surrogate to diesel PM. So diesel PM, again, we do not, but there is no measurement to just to capture diesel exhaust PM. So we have to use different species such as EC or BC as a kind of surrogate to estimate the diesel PM concentrations in the atmosphere. So almost about 10 years ago, we were very successful using EC, which is very similar to BC, as a surrogate to estimate the atmospheric diesel PM concentration. However, over time, especially port area, introducing the truck engines newer than 2010 models, etc., under the states, the incentive program, Proposition 1B, trucks has been cleaned up significantly in 10 years. So nowadays, the diesel PM concentration turns out to be probably lower than EC concentration. So we need a newer methodology to estimate the ambient diesel PM concentration. Ultrafine particle might be one of the way, and then STEB is also looking for the ways using more extensive source the apportionment or PMF or type of analysis to tease out ambient diesel PM concentrations. But then so the bottom line is we are aware of it, but then there is some limitations in it. And then I believe the second part of the question is the equipment instruments to be used and
So I can't quite get into the specifics of what individual things would be put on the April since it's not public. But I mean, I think what we've done is we've taken the priorities from the 3 different communities, and I think we've shown you the array of technologies that could be used in different scenarios. And what we're trying to do is enhance from what we learned from the communities to say, okay, these are things that were identified by the communities, researched some technologies that would be most appropriate, whether we have them in-house or if there's technologies through contractors that if we don't have the in-house capabilities or it would take us a long time to develop and these technologies exist, we would try to reach out to see if those services could be available. So that's the process that we've been going through right now, but realize that this is an ongoing process. So I mean, if things shift or if things are could be improved later on, we have the capability in the future to be able to add on extra capability to address any other gaps that that could exist from this initial plan.
So, by any chance, if any of our answers is not enough to address your concerns or questions, all the staff will remain even after the meeting to go over any questions you have. But then with that, I will move on to the next question. Janet? Okay, the Jesse, please. I was going through this table in this clockwise, anti-clockwise
I'm fine at
rotation,
waiting
but-
too.
Yes, please, Jesse.
Okay, Jason, you had mentioned the 2 goals up there. We want a 3rd goal to be added, and that is accurate emissions inventories in communities. Because if I can't have an accurate emission inventory, then you're wasting our time. Because what's happened is that I've been around 16 years now. I have testified at numerous meetings every single year, and we bring up emission inventories every time. And there's opportunities where other inventories are being done, such as the Port of LA, Port of Long Beach, they're doing their inventories. I have testified at every one of those public hearings, identifying emission sources that are not being identified. In fact, they won't even acknowledge them, even though I put them into my public comments, okay, as a request. And to give you an example, when ports or industries make a decision and part of the responsibility of their services is shifted off property, then they're off property impacts in the community. In this case, we're talking about the Port of LA and Port of Long Beach when they made a decision to go forward in expanding container imports. Well, there are now over 100 container storage yards in Wilmington. So now we have thousands of trucks leaving the freeways, driving every single day, every single hour, every single minute in Wilmington, taking and delivering and picking up empty containers. Okay? There is no inventory for that, and I bring it up every single time. But it's not just PM we're talking about. We're talking about brake dust. Some of these containers are reefer containers, so we call them container graveyards because 90% of them never leave. So we're talking about HFCs now being released into the atmosphere. We bring that up every year at every public hearing, and that's not being done.
Sure. So I think your first question was regarding to emissions inventories, and Dr. Pakbin's presentation, one of the line items was to improve emissions inventories. So, I mean, monitoring information can help produce better. I mean, you saw St. Main's presentation where they're incorporating different data sets from everywhere, which includes monitoring data. So part of the monitoring purpose is to potentially improve certain areas of the emissions
Well,
inventory.
in our AB 617 community plan, you know, there's going to be things that we're going to identify. Okay.
Right,
I
and
don't
that I
want
was
to
going to
foresee
mention.
a conflict where you're going to tell us we don't have the time, we don't have the budget, and we don't have the equipment. It looks like you've already determined, you know, what community and fence line monitoring is going to be done. You've already predetermined equipment that's going to be allocated towards that. Well, that may not be in sync with any of our three communities in AQMD as part of our AB 617 plan. And you may be experts in all types of equipment, with all due respect, but then some of us also do research on equipment. And I reviewed all 6 oil refinery fence line monitoring plans, and not one was acceptable to me. They were not 90%, they were not 80%, they were hovering around the 60% acceptable. Not one put down the manufacturer and model number of a piece of their equipment. And to me, that is important because it also dovetails into the public notification warning system stuff. And they're writing in these plans 5-minute, 10-minute, even quarterly notification to the public. Well, if there's a life-threatening chemical being released, I'll be dead in 5 minutes. I'll be dead in 10 minutes. I'll be dead quarterly. So I want to have input that, you know, I'll pick one, FTIRs. Do you have any FTIR now, presently, you own or on your list to be purchased that can do 1 minute or less intervals,
So,
QA and reporting, yes or no?
so the Fluxens fan is our FTR unit that would be appropriate, but that is on the mobile platform. So to have something to say that it's going to be 24/7 at a particular location.
No, I'm asking, can it do 1 minute or less analysis, QA, and reporting?
The QA part and reporting portion, not.
Okay,
But-
because I know Atmosphere does have an FTIR that can do that.
But I think
Okay,
I think
so
that's going to
where
go
I'm
in.
concerned about, you know,
Sure.
us communities have grave concerns, and if you're not going to buy equipment that can provide us the maximutation or the maximum information or the best information,
If I
that's a
Sure,
concern.
I was going to say
maybe
there was going to be.
address.
Well, let me start.
sure,
I
sure.
think part of the concern is with refineries or specific, entities. Again, I think when you're looking at refineries, they have already in place, like you mentioned, the fence line portion of their monitoring plan. So it is still under review for the refineries of whether those are going to be formally approved for some of them. And with regards to the backup portion, which is the community monitoring that AQMD will be deploying as part of that. So there will be some strategies, and then I think Dr. Polidori will mention a little bit more about the community monitoring portion. So, Andre?
And you know, I think we are mixing a couple of things here. So I think that the question about emissions that's extremely important. But you know what we are referring to with the fence line monitoring. I mean, for the Rule 1180 and fence line monitoring system, we cannot measure emission. We can only measure ambient concentration of the pollutant of interest, right? So with respect to the emission, we started measuring emissions from refineries back in 2015. And that initial effort that Dr. Pakbin was talking about was referring to a 5-week period. But after that, you know, we kept conducting measurements every quarter at least 3 refineries to try to understand better the temporal variability of the emissions itself, right? So the difference there is that the Fluxens van basically is able to measure the column density of whatever VOC is coming out of the refinery. That's how you can calculate an emission rate. But when it comes to Rule 1180 and fence line monitoring, is basically whatever passes through, you know, essentially a laser that goes horizontally, right? So you can detect concentration, but we won't be able to calculate or estimate emissions through that particular program. So I think that is important to differentiate the two. So
Well,
we
that's
do,
why it's important for us to know what are
Sure.
all the limitations and parameters, because if we are identifying a concern and there's a gap, then I want to see in the plan, we're going to close that gap. And you're going to look for equipment to close that gap. And if
most
it takes
definitely.
multiple things to give us an accurate estimate, then hey, we're a team. Let's work towards
Oh,
doing
most
that.
definitely.
But
But
don't
again,
predetermine and purchase equipment that's never going to achieve that. I'm going to have to wait another year before you decide to put it up for a vote, and I'm red flagging it now. Yes, that has its limitations too, to what I'm
Right.
identifying, but at the same time, if we need to have a next week presentation on equipment, then I want to have a next week presentation on the equipment, so that, because you're already judging and making determinations for us without our input.
So, Jesse, the comments are well taken, and then we will all take your comments and then come up with a plan. But so my impression, so what I'd like to mention is, I think you are pointing two kind of stories here. One is the accuracy of emissions inventory, which I cannot agree more with you. So we all need it. We're doing our best and using the state-of-the-art data and the state of the science to come the best available for now, for the time. But so that's, I'd like to emphasize a step continuous effort to refine it, and then any inputs from residents or the advisory group members like you are really precious. So we recommend, we strongly encourage you to provide us your feedback, whether you have specific numbers or areas or concerns, then we can work on it. The second part of your point is emergency response, more like. So one thing is emission. We more like would like to see exposure. Exposure, cancer exposure or exposure estimate is basically the assumption that a resident stays there on the same spot, exposed to the same condition for 70 years. So it's kind of a different methodology and framework. But then I do agree there is emergency response. So let's say there is explosion, hopefully not, but then accidents. Then that has to be prepared properly. That's a part of emergency response system. It's kind of, I think it's kind of parallel discussion, which might need to come up with more brains and then putting together and then see what's available capability or capacity to that end. So, but with that note, to more discussions and the presentation for sure will follow in the next meetings. Next meeting of this one, next meeting of a CSC meeting.
See, because each one of us members representing our communities can give you a list of sources that we feel are not included in the inventory. There's 2 bridges that go from Terminal Island to Wilmington that are lift bridges.
That's
Okay?
all
And
good
so
comments.
every
So
time
we
that bridge goes
welcome
up,
that.
there's
Yeah.
20 minutes
Yes.
of idling from both trains and trucks there that are not included in any emissions. And then one day I was there, all of a sudden I see black smoke coming out of a little building. Well, it turns out when those lift bridges goes up, there is a diesel generator that kicks in because the power it takes to lift it
So
will kill
it's
the grid.
if it's a backup generator, we will go back. We hopefully we continue discussion after the meeting. So let's proceed with the other questions, and again we will stay here to discuss with you.
something very quick, because I think that, I really want to address Jesse's concern about equipment for rural 1180 specifically. So it's not that we are not looking at equipment. I mean, mainly we have been basing the requirements based on detection limits, right? There's different equipment that can get the job done, and that's what we are basing our main concerns on. I mean, you reference atmosphere, and we looked into it, and basically the way that they're able to achieve the detection limit at that particular time resolution is through the use of a developed model that they developed proprietary that they have not been willing to share with us. So I have one person that is almost dedicated, I would say 80% of the time. He has been working with JPL to run a model to basically try to understand if an FTIR using a certain path length and looking for a particular compound like benzene or BTEX can achieve that detection limit at that particular time resolution. The atmosphere is claiming they can do that. So we don't have the final results yet, but I'm telling you that it's going to be very difficult to substantiate theoretically their claim. Again, it would take a very long time to just address this specific technical problem. Would be more than happy to discuss with you, after the meeting.
See, because
Okay,
we want to know trend analysis of chemicals in our community. We've been asking about benzene every year, continuously. Yet AQMD and no government agency has ever shown us any trend analysis. Is it going up or is it going down? Well, I did that. I looked at AQMD's data from 2000 to 2015 for ConocoPhillips Oil Refinery, and it went up. It did not go down, but yet that's never been reported to us. And so there's things that we're aware of. You know, UCLA did an air quality study, which we participated in, and again, using ConocoPhillips refinery, and benzene was discovered only being released at night. Why?
So, okay, Jesse, thank
4-year
you for the
worth of
comments. But-
measurements
Yeah.
that were, taken through an EPA community scale grant. We don't have a final report yet, but it's being finalized. More than willing to share that with you when it's ready.
So we'll continue this discussion after this the meeting, please. So there are other people who would like to raise questions. So next one is Jeanette, please.
Well, and thank you. And I think it's actually good for me to follow on Jesse because I'm going to talk about it maybe at a higher, broader level. First of all, I'm really, really appreciative of this discussion about the differences between modeling, monitoring, and the reported emissions. I think this is really important to understand how the different data sets are collected and how they're all used to characterize emissions, both at the regional and now at the community scale. I think that I wish that we could have that conversation on the state level because I think there's a lot of confusion about the different emission data sources and how we go about characterizing emissions. Right now, though, and in seeing these presentations, which were fabulous, I learned a lot. And in listening to the conversation, what I keep thinking about, though, what do the communities need in terms to support the planning efforts that are underway? And it likely won't be these slides and these data sets because they're very, very complicated. And they don't really paint a holistic or whole picture. So I guess maybe this is a question back to you guys. How can we help? Can we help? What role do you see for this body here? I know that you are working separately on a very robust data display system that will take in both the different monitoring data sets as well as other information that you have. Maybe that's something that we can contribute to, but I think that there is this is going to be very, very difficult for community planners and I mean the CSCs by that to grapple with. So how can we make this manageable to match up to the planning processes going on?
So I will start and then I will have the Jason and Joe K chip in. Technical advisory group. So when we first of all the AQMD and we do our best to make all our data and then analysis and procedure as transparent as possible. But then we experienced in previous CSC meetings some of the technical notes seems to not delivered very well within the given amount of time, and then within with all the members in CSC. So we formed this advisory group we can share or we can go through technical details as much as needed for everybody to be on the same page and then to make ourselves transparent. So the purpose of this meeting is really discuss all the details and then just make sure we are not doing anything behind the door. But then we do acknowledge everybody's expertise and specialties are different. So probably the level of the digestion or ingestion of each community members might slightly differ from the advisory group members sitting here. So, but again, the purpose was that, and with that.
Right. So a great point, Janet. So thank you for that. And again, this is a forum where we can kind of dig into some of these technical details. And again, like Sang-Mi mentioned, it's like we formed this specifically for those folks who feel comfortable and feel capable of having those discussions. Whereas I think some of the feedback that we got when we started showing data in our CSC meetings was pretty negative. That a lot of people just simply did not understand the purpose of it. And I do understand. I think it's a different audience. I think it's important, and I think, everyone here, I think understands the importance of it and appreciates that we're showing it. But this is a more appropriate forum to have those discussions. Of course, we're not doing this in a bubble. These are all public meetings, and I think we do rely on folks here to help communicate those in plain language back to the committee members who may not have that kind of technical background. So as far as how does this technical data support the planning efforts? Well, one of the requirements in statute is that we do a source attribution analysis. So basically an analysis of the various sources of air pollutants within each designated community. So that is what Sang-Mi and her team are working on as part of the AB 617 community plans. But because of the timing of these requirements and our necessary timing in order to bring an item to the board for approval, this effort really needs to be done simultaneously, really needs to be done in parallel to the development of the community plans. That does not mean that we are not using the data to help inform the community plans. Absolutely, it is important, but I would also mention that AB 617 is really a different process from the AQMP, whereas the AQMP has those specific requirements in terms of the analysis and how that leads to the development of the measures and the specifics of that in those plans, whereas AB 617 puts a lot of weight on community input and steering committee input in particular. So that's really what we're looking at, is to look at, I think when I've tried to present the data more recently at the meetings, I've noted it as, this is, at this point, we're sort of using it as a check to make sure we didn't miss anything really big through the emissions inventories. Yes, the emission inventories are able to capture kind of long-term usual emissions. No, there are gaps. Absolutely, there are areas that it doesn't cover, and I think we've tried to be clear about that. It doesn't capture leaks. It doesn't capture fugitives. It doesn't capture some of these other it doesn't capture unknown sources. And again, it's only as good as the data that are available. And as you saw, we're trying to integrate kind of more and better data sources to really enhance that granular picture as much as we can. Now, there's a little bit of balance in terms of the labor and the effort and what that means in terms of these emission reduction plans. Again, I just want to make sure that we are accurately reflecting what we can, the emissions as best we can, but know that that data is not necessarily the only driver of what the priorities are that will be put into the plan. Community input is essential to that. And I think as we develop the specific measures, which is what we're going to be talking about in CSC meeting number 4, I think having some background in what data is available and background in terms of what the community members have expressed through their observations, through their own research, and through their kind of personal priorities as well. I think that's what we're going to use as kind of inputs to this plan. I do want to take half a step back and talk a little bit about kind of like our kind of administrative procedures, that topic that is sure to put many of you to sleep, which is that we are not trying to we're not trying to make the decisions for the community steering committee members, and I hope that for those of you who have participated in our steering committee groups, that you see that we really try to take everyone's input very, very seriously. But I also want to mention that we did not choose these timelines in statute. That a July 1st deadline to begin monitoring is really really aggressive. That's a good thing. It pushes us, but it also means that we have to make some of our best guesses at this time in terms of what equipment purchases we might need to be made. Maybe it won't necessarily be used in one community. Maybe it can be used in another. It comes from the same pot of money, right? And so again, for our kind of administrative planning purposes, that is really essential. Otherwise, we will not be able to hit that July 1st deadline, and that is on us. And so again, we just have to make kind of our best evaluations in terms of, what would serve, what would we need right now, knowing that there may be future opportunities to make adjustments. If we miss something, we can, try to go back to the board at a future date to make any additional purchases that are necessary. It does not mean waiting a year. We do have board meetings every month except August. So, again, administratively, there is some flexibility, but we must hit that July 1st deadline.
And I appreciate that, and I do understand that the district and all of you are working really hard with all of the data to understand the communities, and I appreciate that. I just think you have a lot of very interesting and varied people here today, and I think there may be a role to help distill the work that you are doing down to a more palatable format for the communities, so that when they're doing the planning efforts within each community, that they're better able to leverage the very rich and quality information that you're producing across all of these studies.
Okay, thanks for the comments and questions. So I will have mic to Rafael. Afterwards, I'd like to open up the comments, questions from the public. Go ahead, Rafael.
Thank you. So again, it's, one of the reasons why I asked the question that I did early on was, if you guys could share what you guys want in terms of equipment and what you guys currently have planned, it would be nice for us to know, because, I know that time is of the essence. We got to get things going. There's already probably a comprehensive list. Share it with the community. But, I just have to think back on the goals of what we're doing. And that's to come together and get some sort of community emission reduction plan in place to do what? To protect the public health. And that's our ultimate goal. Year over year, we see that tons and tons and hundreds of thousands of tons of emissions ultimately are released in the air and they fall to the ground. And it's these chemical compounds, these heavy metals, these PM emissions, the soot, etc. They just don't disappear. They get deposited on the ground, and that's where we walk. That's where we live. That's where we spend our day to day. And it's important to understand that, for decades, these emissions are deposited on the ground and ultimately wind up in our streets, and they get into our storm drains, when it rains, goes into our rivers, goes into our beaches and oceans. And we always have to keep that in mind, by the thousands of tons, because it's an accumulative thing. I look at annual emission reports, I see hundreds of tons of benzene, hundreds of tons of heavy metals, hundreds of tons of, just sent out every year. And they just don't disappear. And that's why it's important. And I wanted to know that, and then you guys didn't answer the question the first go around, was what is the agency doing to make these communities aware of the problem, and then providing some sort of suggestion on how to mitigate the pollution that's deposited on these streets?
So I will take up the technical part first. So your observations that there are hundreds of tons of emissions spewing into the air every day, every year. Yes, that's couldn't agree more to that. But then this chemical species has its own life cycle in the air. So some of the heavy metals or the some of the heavy metals deposited to the soil. That's also true. That's why sometimes we do the sampling of resuspended particles. But many of them have limited lifetime. So it does not necessarily just drop in one spot and staying there. So in the air, through this chemical process, it would be dissipated, it would be disappear, it would be transported out to different area, and then during the time, it could be well diluted in the entire atmosphere, and then also that disappears, because when it reaches the final products, it basically get removed, and sometimes rains, of course, that is we call the nature's wet scrubber, meaning that this washes out all the things, and then it goes through the drainage. So I'd like to point out there is a need to distinguish something that might stay in the soil, but most of these chemical species, especially gaseous species, not necessarily. More likely it dissipates away. Secondly, I do believe this the AB 617 effort and then our agency's commitment primarily through the air side. So the water quality and then soil quality, we are not discounting it, but then we do not have direct jurisdiction over it when it comes to controlling. So it could be a challenge for us to police such venues.
It's not policing that I'm referring to. I'm talking about just sharing of information and concerns with communities, with the agency, because there is an interagency forum that AQMD, conducts. I've attended several of them now, with the EJAG communities to talk about specifically EJAG issues. So there is a forum in which this information can get passed, but it hasn't gotten passed. And that's one of the things that I want to make sure that happens is we're talking about this stuff because, to regular planners, all we think about is just, we're very focused in terms of the specific functions that we have to do. We don't wonder about how one industry is being affected by this unless it becomes a problem and it's reported in the press and it becomes a big story, but then it dies down. Most agencies aren't really familiar and aware that literally they have to consider thousands of tons are deposited each year onto city streets, and I'm not talking just deposited into the soil, and then agencies that are responsible for the transportation of this water through collection systems or by means of waterways, they should be made aware of it as well because, again, we have water quality standards and whatnot that we must meet. There's, various, we just had Supreme Court decisions just made because of the pollution within the rivers that are currently taking place. And we have, to deal with this.
Right, and I think that's a very good point. And one of the things that is part of this program, as you notice with the community steering group committees, we have members of sister agencies who can help coordinate some of those where maybe our jurisdiction ends, but we can partner with the appropriate jurisdiction agency. So to your example about the water, we when in Paramount, we made sure that we notified the regional water board so they were aware of potential metals that may be in the water. So we also did inspections with their team to be able to help assess and facilitate that kind of jurisdictional coordination. So I think when we do identify that area of collaboration, community, businesses, we will take that opportunity.
Thank you. Now, any questions or comments from the public? Yes. Yep. Please take the microphone and state who you are.
Tim DeMoss with the Port of LA. There's a lot of discussion about monitoring equipment, and I think Dr. Packman made a comment that for this particular effort that the equipment does not need to be EPA certified. So that sounded a little concerning to me. So I wondered if you could just discuss that a little bit.
Well, some of these monitors that are actually not EPA, like EPA approved, it doesn't mean that the data quality is lower than the EPA approved. In fact, some of them are much more advanced monitoring techniques. EPA is reviewing all of those technologies. This is, for example, the optical remote sensing. It's right now it's under the review. It's currently not approved, but it's actually a much more accurate way of measuring the VOC concentrations. Also, for example, our contract with our partners with Aerodyne and with DRI, they're developing the first type of monitor that can measure Chrome-6 in real time. So obviously this is not EPA approved yet, but it would enhanced our capability to find the sources of emissions for Chrome 6 instead of like deploying like tens of monitors in different locations and wait for 24 hours to collect the sample, wait another day to do the chemical analysis, and then the reporting. So when I said like not EPA, it doesn't have to be necessarily EPA approved. It doesn't mean the data quality is lower. In fact, in some cases, the data quality is much higher.
So let me take a step back, and I think I know where you're going with this. So there's different levels of data quality that Dr. Brockman had mentioned, but there's certain levels, depending on what method is used, that certain types of actions can be warranted. So for example, for compliance level type of action, well, then you do need the kind of certified or EPA approved or guidance methods that would be appropriate for doing some compliance action. But as Dr. Packman mentioned, I mean, you know, this is a program that we can use some other techniques to help us maybe investigate certain areas that we might not been able to get to with traditional methods, and we can use those advanced technologies to essentially cast a wider net to kind of say, okay, let's do a survey to kind of get some preliminary information of where we can deploy you know, other types of resources if warranted. Again, we're here to do an assessment if this is part of the prioritization and if air monitoring is the appropriate tool to be able to do that, is to provide that information. First assess at the survey level, and then if we do see something that is of concern, absolutely deploy something that if it does require some sort of compliance action, then we deploy the appropriate methods that could get us there.
All right. I guess my main concern is just like the small handheld devices that people might have, individuals might have, and I would be concerned if those were not EPA certified and they were trying to make arguments with respect to the levels that they were getting on those devices.
Next, please.
Hi, good morning. I'm David Pettit from NRDC. I have a question about mobile source monitoring, in particular hyperlocal and hotspot mobile source monitoring. There are intersections in neighborhoods, for example, around the LA ports, where there's a very high concentration daily of diesel truck trips carrying cargo to and from the ports. And I'm wondering if any part of the monitoring or regulation that you folks are doing in connection with AB 617 will take into account those hotspots or particular intersections, and if the answer is yes, how do you intend to do that?
Mobile source hotspots, first of all, this traffic sensor data is provide the first level of the data because it is literally real time and everywhere, entire basin, not just those communities. And then secondly, there are more enhanced efforts that under discussions are kind of utilizing more like optical devices to actually monitor and then track the traffic activities of a certain area that's identified as a hotspot, for example, the warehouses, etc. So those can assist to further refine the traffic information. But if the optical data is not just the traffic volume, because volume itself can be handled by sensor data, but then this optical assistant would contribute to identify, for example, the age or vintage of the vehicles, and then like activities such as idling, or even another concern, one of the other concerns raised is the refrigerating units that's on during this special types of warehouses can be assisted through these optical devices. So those are the areas that staff plan to improve.
And one quick comment on the monitoring side. I mean, some of these mobile laboratory that we have, they are equipped with black carbon instrumentation, volatile organic compounds instrumentation, NO2, CO, PM 2.5. So I mean, again, you know, there are different purposes for the monitoring survey, one of which is to potentially try to identify intersection when the concentration. Oh, absolutely, yeah. Right. Definitely, and you know, again, you know, it could be a wide area survey, But we definitely would like to keep your recommendation into account. If you tell us there's this particular intersection in this particular part of town that we would like you to check, we'll definitely go there.
So I just want to make a quick comment about kind of how to address hotspots. I think you're talking about how to alleviate idling or reduce emissions in those hotspots. So I'll answer it in two different ways. So one, I think Sangmi alluded to, if there are specific intersections or a segment of a roadway where it's identified as an idling problem, then we could potentially look to put some of our resources into those very, very specific areas for idling sweeps, right? To make sure that everyone's within the rule, complying with the rules when it comes to idling. We can also use data to try to target the frequent flyer trucks that go through that community, not just in the one hotspot, but maybe in several hotspots that were identified by the community members as priority areas where they observe a lot of trucks. Again, trying to target incentives, to those trucks that most frequently come along those roadways. I think if you look at hotspot as a little bit of a broader topic, we're talking about warehouses or ports and so on. I'm sure you're well aware that we're working on the indirect source rules, facility-based measures, and so that's going through that process. With regard to ports and airports, we're working on the MOUs at this time.
Any further questions from the public?
I have a quick question.
Okay.
Might be a comment. I just want to stress the importance that the data that we create supports the emissions reduction plan, because at the end of the day, a lot of our communities, I'm coming from San Bernardino, Muscoy, have been studied, and we do know the amount of black carbon, and we do know the types of chemicals that are in the air, and so we want to just build off of that, really, right? And we also want that the studies and the data that we get supports our advocacy so that we can work on regulations and then we can work on compliance efforts, because at the end of the day, we do know the sources and we understand because we've been living there for so long. And so just want to stress the importance of that data being able to support those types of efforts that the community will bring forward when we tell you all what we want for our emissions reduction plan.
Absolutely, that's a great point, Andrea, and thank you for that. Just as an example, we did some. We've done a lot of fugitive dust monitoring around various facilities, either through as part of complaint response or as part of implementing various types of kind of community monitoring plans, and that has really helped us identify specific facilities that had problems with fugitive dust. And I know in particular San Bernardino, Muscoy, a couple cement facilities were raised as community concerns. We have done some monitoring near cement batch plants, and identified a facility that had an issue. This is the one we monitored was not in that community, but we ultimately worked with the facility to make improvements at that facility, and then the monitoring actually showed significant reductions. So basically demonstrating that the changes that they made were effective.
Thank you. So if there is no further questions, looks like we are close to adjourn the current meeting. Oh, Jesse.
A reference was made to the AQMP, the Air Quality Management Plan. Never has there ever been one environmental justice community in the whole South Coast State community that has ever endorsed the AQMP plan. Not one has ever been acceptable to us. They typically have always done the minimum to get by, and they've always traditionally left out certain major industries. In our case, oil refineries have never had any major requirements for any new reductions in the last 15 years, that we can see. So I want to clarify that.
Thanks.
References are made to the MATES 4 or MATES 5 study. I want to request in all future MATES studies that every AB 61 disadvantaged community be included. Wilmington is well known to be a major hotspot community. And I believe there was backroom politics It was taken out of the MATES 3, the MATES 4, and the MATES 5 study. That should not have happened. I don't care what the reason was. That should never happen again or happen to any other community. So therefore, we request in all futures, every AQM AB 617 be included in the MATES studies.
Okay, Jesse, thanks for the comments, and then we'll make sure. So first of all, there is the newsletter sign up. So that is kind of the very first step. You would be aware of all the activities, the AQMD activities going on in AQMD. So please do make sure that whoever interested in AQMP or MATES 5 activities sign up the newsletter. In addition to that, if you have any interest, send the email to the AB617_TAG email. I will make sure you will be in the right distribution list so you get the information. And in addition to that, all the meetings and data, even this emission data and modeling data, exposure data, all of them are basically public data. So you can request such data, then STEP can go over to explain the formats and the meanings and implications. I mean, not probably less of implication, but meanings of data and then how to handle such data. STEP will be happy to assist that as well. And then, but in general, thank you very much for your comment, and it's well noted. So with this, I think we adjourn the current meetings, and then this technical advisory group meeting will be happening kind of regularly until we develop a SERP. So next meeting will be scheduled in 2 to 3 month time period, and then STEP will diligently notify the date as soon as it is set up. And then in the meantime, if there is any specific topics you need more assistance or the clarifications, etc., please feel free to contact us. This email address of ab617_TAG@aqmd.gov is active email, so STEP can receive the emails and comments on it. And then
I guess this is just, is this on? Okay. And this is just a follow-up to Jesse, because I'm part of the MATES tag. There was a localized refinery part of the MATES 5 study, correct? Or no? Yes? Okay. Just checking. Thanks. Okay.
Okay, thanks. And the last item is there is an optional tour for the TAG members, a tour to lab and AQ spec capabilities in AQMD. Whoever interested can contact Andrea and then Aaron, who is sitting on that side of the table. And mobile laboratory. So with this, we adjourn today's meeting. And if you have further questions, comments, we will be available here. Thank you. Thank you for participating in these meetings and then your input to the meeting. Thank you.
Excuse me, quick question. Who is there anybody that is interested in the lab tour? Can you raise your hands just to have a quick count? All right, at least 5, 6 people. The lab tour, yeah, for IQSpec. Okay. Another second tour, no? It has not changed, no? Okay, sounds good. So let me grab the other individuals.